I need to correct something. I literally walked away from this video and was like, what? So I just want to go back in and correct it now. Hopefully, well, you should watch these fairly close together. Yeah, it's this last one. I'm gonna put it down to the fact that it's early in the morning. So find the work done. So find the work done in bringing a 1,000 kilogram car from rest to 30 in 10 seconds. Okay, so all of the stuff in pink is completely correct. That's absolutely fine, I think. I did some stupid in that as well, but I don't think I did. No, you can tell me if I did. Now, the mass. Okay. We are not... The work being done on this car is to exert a force on this car to move it from rest to 30 through 10. That's the force that's been exerted on the car. There's no force been exerted on the car attempting to lift it against gravity. Okay, I don't know if you questioned this when I was doing it, but oh, sorry. I think that was just because I had done the previous one. It's my excuse anyway. So what we're trying to figure out is we've been given the mass and we're trying to figure out the force needed to bring the car from rest to 30 in 10 seconds. Okay, so we're not talking about a vertical force here. We're not talking about its weight because we're not at any point attempting to move it, like to lift it. That's not what we're trying to do here. So in order to work out the force, so to bring a car from rest to 30 in 10 seconds means we're going to change its velocity in a given time. So we're going to get the car to accelerate. Okay, we know that because we calculate acceleration in pink. So we need to work out what force will cause a car of this mass to undergo that acceleration. Yeah? We have a formula for that. So what force will cause a car of mass 1,000 kilograms to go through an acceleration as described above? Okay, and that's the formula. It's F equals ma. So the force we're calculating here is the 1,000 kilogram car. The acceleration is 3 because that's over on the side. Sorry, it's gone a bit slow. There you go. So the force that is required to get this car to move from rest to 30 in 10 seconds is 3,000 newtons. That's the force required. If you want to lift it, it's going to be 9,800, but nothing in this question mentions lifting it, so there was no reason to multiply it by gravity. So I am sorry about that. So it's 3,000 is my force that's going to be required. So I'm just going to remove the other one and put that in. And then I'm going to multiply 3,000 by 150. And that gives me 4, 5, 1, 2, 3, 4 joules. So 450,000 joules. Okay, sorry about that. It is literally just, as I tell you all the time, read the question. So make sure that, like, the only reason we multiplied the guy who was carrying up the stairs, his bag, by gravity is because he was lifting it against gravity. He had to counteract gravity. We had Newton's third law. You had to balance out the gravity. The car wasn't being lifted. The car is staying on the ground. So the force is a horizontal force. So when we calculate vertical force, we take gravity into account, but we weren't calculating horizontal force, and that's F equals ma. All right. So sorry about that. Yeah, just take that into account when you're doing your homework.